So here we have a vector application problem where we have an airplane that is going in a certain direction and a wind that is going in another direction. So let's draw this. So the airplane is at 45 degrees from due north, so 0 degrees is here, east is 90 degrees, so 45 degrees is exactly northeast. And we have a wind, oh, it's going 250 miles an hour, by the way. And there's a wind that's blowing from the north, which means it's going to the south. So we can draw that from your origin, going to the south, and it's blowing at 30 miles an hour. So one way to do this is by putting the wind vector at the tip of the airplane vector. So that side is 30. And the resulting vector will be a little bit of a southward push and a little bit slower because it's flying into a headwind. So this will be the resulting direction and speed of the plane, which is exactly one we want to find out. So here we're going to use the law of cosines to solve this one. So in order to use the law of cosines, I have to figure out one of these angles. So I do that with some geometry. This wind vector is parallel to this wind vector, and this plane is flying at 45 degrees here, so this one is going to be 45 degrees there. Those are alternate interior angles, so they are always congruent. So let me see if I can blow this up some. Write 45 in here so that we know that's 45 degrees. So if we want to figure out this, the resultant, we're going to use the law of cosines, which says x squared equals 30 squared plus 250 squared minus 2 times 30 times the times 250, sorry, 250 goes here, times the cosine of 45. We're always solving for the side across from the angle that we know. So if this is the side we're looking for, that's the angle across. Putting all this into our calculator, we get an answer of 229.77 miles per hour as the ground speed of the plane. So now to find the course of the plane, we're going to use the law of sines and figure out what this little angle is right here. Okay, so 30 over the sine of that angle, we always use the opposite side, equals 229.77 over the sine of 45. Because this x side, the resultant, was opposite 45. So when we do this calculation, we take the inverse sine of 30 times the sine of 45 divided by 229.77. Okay, cross multiply here, divide by this number, take the inverse sine, and that angle happens to be 5.3 degrees. So if I want to figure out what the actual bearing is, that's from our due north to the green line, I have to add that to our original 45 degrees, and that heading is going to be 50.3 degrees east of north. So the plane is flying at 229.77 at a 50.3 degree angle east of north.